implemented now. So today we're going to go over chapter 11, project quality management, and chapter 12 is going to be time and cost control. Okay, so let's get started. Chapter 11 in your textbook is 288, page 288. So let's define what project quality management is. It's creating and following policies and procedures to ensure that a project meets the defined needs and was intended to meet to be intended to met from the customer's perspective. Okay, so what does that tell us? So we have to produce a finished product, right? And that finished product has to conform to some quality requirements represented in the RFP or contract documents. So whatever the client owner wants to see as its finished product is what they're going to be looking for. They want to see that all those matrices and those checklists and those all those finished products and materials that are to be used, they're all being implemented as part of the construction project. So, like we know, we have the three parameters when it comes to construction. We have our cost, time, and quality. You see that on page 289 of your textbook, figure 11-1. Okay, moving on. So, how do we go about managing this quality? We want quality work, but how do we manage it? So, we have three processes. The first is we plan for quality. What is quality and how will we ensure it? We perform quality assurance. Are we following the quality standards that are set forth in the standards, the RFP, contract documents, the quality management plan? So are we following what has been set forth as our standard? And performing quality control. Are we meeting the quality standards? So the first is plan quality, perform quality assurance, and perform quality control. Okay. So now we're going to define what is quality assurance. Okay, so quality assurance is the process of auditing the quality requirements and the results from quality control measurements to ensure appropriate quality standards and operational definitions are used. Also, continuous process improvement reduces waste and eliminates activities that do not add value. Okay, so what does this tell us about quality assurance? To sum it up, quality assurance is basically going to be the checks and are these standards being met? What are the control measures? Are those measures being implemented? Are those measures being met? So, for example, a quality assurance example would be, say we have a checklist, right? So we have a concrete checklist, a part of our quality control. Now, the checklist, is it actually being used out there in the field? That's A. B, is the checklist being processed correctly? So are we marking off the yes, no boxes correctly? Are we getting the signatures as the checklist tells us to get? Let's say we want the field engineer and the inspector to sign off both on the checklist, or we want the third party inspection agency to sign off on the checklist. Is that being done? So when we do our quality assurance measurements or audits of the checklist, we want to make sure that that checklist is being done correctly. It's being used correctly. It's being implemented, a part of the daily work report. So we want to see it being tracked and represented properly. So that's just an example of what quality assurance would be. So moving on now to quality assurance flow chart. So this is something I got not from the textbook, but just wanted to mention it really quickly. So we have our inputs, we have our tools and techniques, and we have our output. So the input for quality assurance would be the project management plan, quality matrix, work performance information, quality control measurements. Tools and techniques, we would perform quality and quality control tools and techniques, quality audits, and process analysis. Output would be organizational process assets updates, change requests, project management plan updates, and project document updates. So again, this is not from your textbook. This is just something I wanted to add. Now we're going to go to tools and techniques. So we're going to choose this center one right here. So tools and techniques. So plan quality and perform quality control tools and techniques. Quality audits. So we identify all the good best practices being implemented, identify all the gaps, shortcomings, share the good practices introduced or implemented, proactively offer assistance in a positive manner, and highlight contributions of each audit in the lessons learned. Process analysis examines problems experienced, constraints experienced, and non value added activities, includes root cause analysis to develop the required preventive actions. So let's look at the first one. The first one is for plan quality and perform quality control tools and techniques. So what are the tools and techniques that are going to be used to meet this quality assurance plan that we have in place? So we would need quality control tools. So what are some examples of quality control tools? An example would be testing and inspection, right? When we test and inspect, that's how we perform our quality control. Those are going to be our techniques. What are some tools? There's going to be some. Let's say we have concrete inspection coming in. They're going to have their tools: asphalt inspection, bolt inspection, structural steel inspection. So those are going to be listed as our tools for inspecting the work. Quality audits now. Identify all good best practices being implemented. When you have quality assurance, that means that there's quality audits being done. Quality audits, as I mentioned with the checklist, is you want to make sure that something that we've already presented to be part of our quality control measure is being done correctly. So we do the audits. An example of this would be, let's say we have, let's think of something. Let's say the contractor, let's go with administrative checklists. So you're being given by the contractor certified payrolls. So you're checking the certified payroll, What are you checking against that payroll? What are you doing? How are you making sure that the pay rate is correct? So as a quality control measure, you're going to be using prevailing wages. Now, this is just as an example. You're using prevailing wages to make sure that the wage being shown in the certified payroll is correct, right? That they're being paid correctly. So when the quality audit comes in and they're up to the stage of administrative checks, they're making sure that you have actually done this check, that the quality control team has done this, that they have actually had the prevailing wage one side of their desk, and then they have the certified payrolls there, and they're doing the checks. They're making sure that it's actually correct. So quality assurance has to come in and make sure: are you doing that check? Is that being done correctly? Another quality assurance tool to be implemented, or an audit that happens, is the daily work reports. Are the daily work reports that are being generated, are they using the latest revision drawing? Are they using a submittal that has been signed and sealed, stamped? Are they using everything up to date? So that's going to be another example of an audit when it comes to them looking at the DWR, making sure that all the information there is correct. So process analysis examines problems, experience, constraints, experience, and non-value added activities, includes root cause analysis, develop required preventative action. Now this example I can give you as a non-conformance report. So let's say you have these non-conformances, they keep on coming onto the project, and you start seeing um, a chain of events that keep reoccurring, right? So you want to make sure that when you're performing these quality assurance on the project, you're able to say, I believe that we could do something different here. We could have something else in place to eliminate these deficiencies that keep reoccurring. We should be looking at a different process. Maybe for example, if we're having poor concrete, uh, visual concrete inspection, in the end, the concrete doesn't look so good. We could start looking, are the checklists for concrete placement, are they being utilized? Let's say, okay, they are being utilized. The checklists are being utilized. But are there hold points on that checklist? Are we supposed to stop the pour? Is there anything on the checklist that makes us stop the pour? Is there something that we could document? Is this being tracked on this checklist? Are the results of the slump, the air, are they being put on that checklist? What else can we do to avoid this deficiency? So quality assurance is going to be looking at that. They're going to be processing all the analysis, all the information that they have to prevent these issues from reoccurring. So that's tools and techniques for quality assurance. Now we're going to go on to quality control. We could have said this before we went to quality assurance, but that's the way I guess maybe a textbook had it laid out. So what is quality control? So quality control is the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary change. So like I stated, quality control is going to be your inspector going out there and inspecting the construction process. He or she is monitoring, they're recording results, either their results or a third party comes in and they record their results and put it in a DWR report. Quality control is often performed by a quality control department. Usually the contractor is the one performing quality control. Not always the case, because sometimes, if depending on your procurement process, your contract, your delivery system, um, it's sometimes an independent engineering firm that performs quality control. Like on my project, it's a design build project. So the design builder has to employ an independent quality control team to perform quality control, because sometimes with, let's say, previously or design build project, the contractor performs its own quality control measures. So they hire all